Welcome to O'Reilly Maths. This is the Leaving Cert paper higher level from 2022 and we're looking at question number 2. Part A. We're given a function g of x is equal to 2x squared plus 5x plus 6 where x is an element of the real set, and we're asked to find the integral of this function g of x with respect to x. Okay, so the integral of g of x with respect to x is equal to, and you raise the power and then you put it over that power as a fraction, plus 5x squared over 2 plus 6x over 1, or 6x, plus the constant of integration. That's straightforward first part. Okay, part B. The diagram shows the graph of a function f of x is equal to ax squared plus bx plus c. So it's a quadratic function where a, b, and c are elements of the set of integers. 3 regions on the diagram are marked K, L, and N. You can see them here. Each of these regions is bounded by the x-axis and the graph of the function x, see there, and 2 vertical lines. Okay, so this vertical line and this vertical line. So you can see that's the bounded is the outside, the perimeter of it, I guess. Part 1 says the area of region K is 538 square units. Use integration of the function f of x to show that 4a plus 3b plus 3c equals 807. Okay, well the key bit of info here is that the area of region K is 538 square units. Okay, now region K, remember, when you integrate, what you're doing is you're finding the area under the curve. So here's the curve. So when the region K is the area under this curve between the x values of 0 and 2. Okay, so that's how we find the area K. So we can set that up there. We can say that the integral of the function ax squared plus bx plus c, the integral of that function with respect to x between 0 and 2 is equal to 538 square units. So we're setting this equation up based on this information. And we're hoping from this now that this information here is going to kind of come out. So let's apply this. Well, the integral of ax squared is ax cubed over 3. So just like we did in part A, we're going to integrate now each term of this polynomial, plus bx squared over 2 plus cx. And remember, it's between 0 and 2. That's going to be equal to 538. Okay. So we're going to keep going here. So now we're going to put in these values of 2 in for x. So if we put 2 in for x first, we get a times 2 cubed over 3 plus b times 2 squared over 2 plus c times 2. And then that's going to be minus, putting 0 in then for all these terms. So if we put 0 in here for x, you're going to get a by 0 cubed over 3. That's going to be 0, so that term will be 0. When you put 0 in here for x, this fraction becomes 0. And when you put 0 in here for x, c times 0 is 0. So we're going to be subtracting 0 from all of this is equal to 538. I'm not going to sub in 0 for every term here because it all just works out to be 0. Okay, so now we've set up our equation. And remember, we're trying to get to this here. 4a plus 3b plus 3c is equal to 807. Okay, so let's tidy up a bit. That's got, 2 cubed, not 2 squared. 2 cubed is 8. So you've got 8a over 3 plus 2 squared is 4b over 2 plus 2c equals 538. So now we want to get rid of fractions because we don't have any fractions here. So if we multiply everything by 3 first, so we can multiply, well, we can multiply everything by the common denominator, the lowest common denominator of 3 and 2, which is 6. So if I multiply this by 6, I get 16a. If I multiply this by 6, I get 12b. This by 6 is 12c. And 538 by 6 is 3228. Okay. And now you can see I've almost got this here. If I just divide everything across by 4, if I divide across by 4, I've got 4a plus 3b plus 3c. I'll just check that that does divide by 4. That does give me 807. So I've shown what I was asked to show. Use integration to show that this is the case. So there we go, that's the first bit. Okay, part 2 then says the areas of the 3 regions KL and N give the following 3 equations, including the equation from part B1. So they're the 3 equations. Now the first one we had shown, the other 2 they give to us. And they ask us to solve these equations to find the values of A, B, and C. So this is simultaneous equations, 3 equations with 3 variables in each. It's not too bad though, because you can see that we've got 3c, 3c, 3c appearing in all 3 equations. So if I number these equations, if I call this equation 1, this equation 2, and this equation 3. So we're going to take 2 different pairs and eliminate one of the variables. So if I subtract the first equation from the second one, and if I do that up, if I subtract up, in other words, 28a minus 4a is 24a. 9b minus 3b is positive 6b. 3c minus 3c is 0. And 879 minus 807 is 72. Then if I subtract the second equation from the third equation, again doing it upwards, subtracting up, so 76a minus 28a, 76 minus 28, that's 48a. 15b minus 9b is 6b. 3c minus 3c is 0. And 663 minus 879 is minus 216. You can do them on the calculator, as I am there. Okay, so now, that's not a minus there, just get rid of that. So now we've got 2 equations with 2 unknowns in each. So this is going to be nice and easy to, I'm going to subtract upwards again here. So 48a minus 24a, that's 24a. 6b minus 6b, they cancel. And minus 216 minus 72. So minus 216 minus 72, minus 288. So A then will be equal to minus 288 divided by 24. Divide both sides by 24. And that gives us minus 12. So A is equal to minus 12 or negative 12. So I found A. Okay, so now I can plug this value A. I can plug that now back into one of these equations. So I could plug it in here for A. If I do that, that equation then becomes 24 by minus 12 plus 6 plus 6b equals 72. So again, you'll see there, I just put the minus 12 in there. 24 by minus 12 is minus 288 plus 6b is 72. I'm going to bring the minus 288 across to the other side. That'll give me 6b is equal to 72 plus 288, which is 360. So if 6b is equal to 360, that means that b is equal to 60. 360 divided by 6. And that's my second value for b. So now I'm going to take that value of b and I'm going to plug that back in somewhere else. So the value b here, I'm going to take that and I'm going to plug that back into this equation here. Again, sorry, I have b. So sorry, I need to find c. So I'm going to have to plug this back into one of the original equations. Okay, so I'm going to plug it in here for that b there. So see equation 1. So equation 1 now becomes 4a plus 3, instead of b now I'm going to put in the 60. Taking this equation here, look. You do it with any of the equations, plus 3c equals 807. And I actually have a already, don't I? So instead of 4a, it's going to be 4 times a, which was minus 12. So I can still be an a and b now, okay? So just to be clear, there's our 60. There's our minus 12 for a and b. And now I just have to find c there. So 4 minus 12 is minus 48. 3 by 60 is 180. Plus 3c, that's a plus there, is equal to 807. Bring the minus 48 and the plus 180 across and change the sign. And what have we got? We've got 3c is equal to 807 plus 48 minus 180 is 675. So c will be 675 divided by 3, which is 225. So now we've solved these equations to find the values of a, b, and c. A is minus 12, b is 60, and c is 225.